Hi, I'm Melanie. I'm 12 years old and I just barely graduated from the Hurricane Intermediate School, and I will be going into 8th grade in the Hurricane Middle School. And this is my dad, and we are not from California.
That's right. We're both right here from Hurricane, Utah. Our family extends out here in Hurricane, Utah for generations. My ancestors helped dig the Hurricane Canal, and over here at the Hurricane Museum, you can find their pictures up on the wall. Okay? So we've been here for generations now, and I graduated high school right here at Hurricane High School. I got my bachelor's degree of science right over there at the time it was called Dixie State University. Now it's Utah Tech. So we are both products of the local education system. So I did mention there's going to be times throughout this where we're going to open it up for the audience. I tried to talk to the high school teachers. I talked to all the high school teachers. I talked to all of the professors over there at Utah Tech, and no one wanted to debate me. And so I'm like, okay, fine, I'll just do a debate against the audience and see who has questions and stuff, and I can answer it that way. So we've got segmented times, so we'll kind of present our points, and then we'll ask you guys about that. So, let's see. I mentioned I graduated high school in 2006. I got my bachelor's degree of science in 2015. And then 1 year after that, 1 year after getting my bachelor's of science, that's when a coworker of mine came up to me and said, hey, did you know that there's flat earthers out there? People who believe that the earth is flat? I'm like, what? No way. I thought it was the dumbest thing in the world, right? People in our day, what are you talking about? And so it's like, yeah, go check it out. And so he kind of showed me a few websites and a few of the popular flat earthers around at the time. And I started looking into it, and I was like, whoa, maybe there's something here after all. And so I'm also a Miro ambassador. Okay? A Miro ambassador, Miro is just a website, okay, that takes communication to the next level. Especially when it comes to making conspiracy boards, which is what we have over here. You've seen a lot of these in detective movies. We just watched Dogman recently, and they made a huge string board of Dogman trying to put their detective work to the test. Okay? So Miro is kind of a board that really just helps make that to the next level. This is just a typical Facebook conversation I had with someone. Okay? And you'll notice all of this is a single comment. He's got like 100 different points, bullet points in a single comment that he's responding to. All in one comment. And over here on Facebook, you'll notice that they've got these little white lines on the side. Okay, those are called threads. And what I like to say is, okay, this is the Facebook format, except for he's taken all of his 100 points and putting them into 1 point. Trying to respond to all of that in a single little comment is crazy. Okay? You can't really respond to all that in a single little comment. So what I really like about Miro is it allows you to branch out. I'm not going to be talking about Miro the whole time here. I promise we're going to get to this. I just wanted to let you know about this because this is kind of my base of operations. Because right here, it allows you to get some elbow room. Being able to go from point 1 to point 2, point 3, on that, which you don't have on Discord, you don't have that on Facebook, even though they got the threads, but you can kind of see how that works. So this here is right out of my high school textbook. This is called concept mapping. You notice that the formatting follows the same thing. So, like I say, okay, with Facebook, you have threads. With Miro, you can create tapestries. So that's Facebook, Miro, I can get as many as I want. And there's no constant scrolling way up to try and find out what someone said just barely. Okay, you just zoom out and it's all right there. Pretty easy. Okay? This is really important because science is systematized knowledge in general. The definition of science is Systematic knowledge of the physical or material world gained through observation and experimentation. So the way you organize your information is essential when it comes to science. So I'll kind of do a tour of this end at the end, kind of showing you around my base of operations, but we'll kind of continue on here.
Okay, that's enough about us. We want to hear about you. Are there any Bible believers in here? Okay.
Yeah!
Got some? Okay. Did you know that the Bible actually teaches that the earth is flat? Isaiah 66:1 says, "Thus saith the Lord, the heaven is my throne, and the earth is my footstool. Where is the house that ye build unto me, and where is the place of my rest?" So this is describing the earth as a footstool, which does not mean round, it means flat and still. 1 Samuel 2:8, "He raiseth up the poor out of the dust, and lifteth up the beggar from the dunghill, to set them among princes, and to make them inherit the throne of glory. For the pillars of the earth are the Lord's, and he hath set the world upon them." So this is also the earth, and it's got pillars, which NASA never says anything about that. Psalm 93:1, "The Lord reigneth, he is clothed with majesty. The Lord is clothed with strength, wherewith he hath girded himself. The world is also established, that it cannot be moved." So the world is staying still, not moving in circles and all of that. And it's got pillars and it's flat like a footstool.
The exact opposite of everything that NASA and mainstream science claims.
The earth takes shape like clay under a seal. Its features stand out like those of a garment. Job 38:14. So the earth is sort of like a coin. It's flat, but the ridges are still there. We're not ignoring the point that we have mountains, but it's still flat. Isaiah 40:22. "It is he that sitteth upon the circle of the earth, and the inhabitants thereof are as grasshoppers, that stretcheth out the heavens as a curtain, and spreadeth them out as a tent to dwell in." So, from God's perspective, like everything is small, like little grasshoppers, and then what's it called?
Heavens, the firmament.
The firmament. That's heaven, spread out as a curtain and a tent to dwell in.
We get this perspective of God looking down on us. And so if we were to go stand on top of a big mountain, I've seen many times all the little tiny cars that are down below us. So this is kind of, instead of cars, it's grasshoppers for them. Kind of talking about God's perspective.
This is the John G. Abbasid map, and it's just like the main idea of like the flat Earth map. Like there's south, and then north is in the middle, and that's the equator. The sun goes around, not under the world. And then this is the Gleason map, and you can still see like sort of where north is and south and east. And it's the exact, like the United Nations used that exact picture for their logo. It's just rotated. So you can see it and it's rotated. And they use it for that. And the International Civil Aviation Organization. They also use it in the International Maritime Organization and the World Meteorological Organization.
Yeah, good job. That's a hard one to say.
And then the World Health Organization, which was very popular in 2020.
Kind of interesting how it's so out there. Why are they using that map of all maps? It's kind of a cool thing. So, do we have any Latter-day Saints in here? This is Utah. You got one Latter-day Saint. Oh, couple. Yeah. Okay. So I'll just let you know ahead of time. Okay. We're both Latter-day Saints too. Okay. We're over there in the Verkin 3rd Ward, and believe it or not, this is actually something that's also taught right here in the Book of Mormon. It's going to sound a little bit like a Sunday school lesson for a moment, so bear with me. Okay. So we got right here, we've heard of Lehi's vision, okay, of the iron rod. Okay, Lehi is following the same biblical cosmology, and he's saying, I saw a large and spacious field as if it had been a world. Okay, in this vision of the iron rod and the tree of life and all that. So according to Lehi, he's not going out and saying, oh, I saw this large and spacious ball of it as if it had been a world. No, he's saying a field. Okay, a field is a large flat surface. Okay, so according to Lehi, okay, this field is like a world. Okay, it's flat. Now this one's really important too. Okay, this is in our Pearl of Great Price. This is Moses chapter 1. It says, and it came to pass, as the voice was still speaking, Moses cast his eyes and beheld the earth, yea, even all of it. And there was not a particle of it which he did not behold, discerning it by the Spirit of God. Okay? Moses saw the entire earth, every particle of it. Okay? Where do we get all of our flat-earth cosmology in the Bible? Who taught Lehi? This is all stuff that was passed on from generation to generation. And when it comes to like this whole cosmology here, you got to think about who followed right after Moses. Okay? It was Joshua. Okay? Joshua is the one who famously said, looked at in the sky and said, "Sun, stand thou still." And, okay, and it stood still. Okay, and so they could continue on their war. And why would Moses, if he saw the entire earth, okay, and if it was as NASA claimed, moving around all over the place, why would he say, "Sun, stand thou still," if it's normally standing still? This is what makes sense here. So this is also really important. This is part of our Latter-day Saint foundation here. Okay, this is the Book of Mormon promise. I also served a mission for 2 years, and this was really near and dear to us on the mission. Very important. Okay, and when ye shall receive these things, I would exhort you that you would ask God, the eternal Father, in the name of Christ, if these things are not true. And if ye shall ask with a sincere heart, with real intent, having faith in Christ, he will manifest the truth of it unto you by the power of the Holy Ghost. And by the power of the Holy Ghost, ye may know the truth of all things. We often refer to this in talking about the Book of Mormon. But no place in this does it ever say, limit it to just the Book of Mormon. Okay? We should pray always. Okay? Why not take the same challenge to our science textbooks? Going back to the Bible here, this is James 1:5. If any of you lack wisdom, let him ask of God, and give it to all men liberally, and upbraid it not, and it shall be given him. So, this is kind of one of those things that for me, kind of my foundation here. You know, I wanted to go and pray about that. But my situation was a little bit unique. I know some people who've had these big burst moments where they get that strong revelation and confirmation saying that the earth is flat. But for me, it's been a little bit different. I won't say I haven't had any confirmations. Okay? I've had confirmations of this, but my experience has been a little bit different because it's kind of been more along the lines of, take a look at this, tell me what you see. Take a look at that, and tell me what you see. And I've literally felt like I've just kind of held up my hands and things have just kind of fallen into them that I just had to share. And so kind of that missionary spirit in me says, you find the truth, you share it. So this is one of those things that really stood out to me.
There is a crisis in cosmology. Usually in science, if we're off by a factor of 2 or a factor of 10, we call that horrible. We say something's wrong with the theory. We're off by a factor of 10. However, in cosmology, we're off by a factor of 10 to the 120. That is 1 with 120 zeros after it. This is the largest mismatch between theory and experiment in the history of science.
The largest mismatch in the history of science. He's a globe earther, by the way. This is Dr. Michio Kaku, and he's a professor who teaches over at the City College of New York. you only say you're off by a factor of 10 to the 120 if you are really dead certain you're wrong about something. That you know you're wrong about that. This is one of those other things that really stood out to me. Kind of take a look at this and tell me what you see. This is a balloon in a vacuum chamber. Okay? We know that when you put a balloon in a vacuum chamber, when you start to pull that air out of the vacuum chamber, that balloon starts to get bigger and bigger until it fills up the entire vacuum chamber. This is just a principle of science that we're able to observe. Observe and behold. Now, how does NASA claim stars are formed? NASA claims stars are formed by gas clumping together in the vacuum of space until it gets so dense that it eventually explodes and turns into a star. Okay? This is the exact opposite of everything we observe in reality. Okay? Part of that big, giant mismatch, a problem in a crisis in cosmology. Okay? I'll share this with you too because it kind of goes a little farther than that. It's got really big implementations. It's not just concerning stars. It gets a lot more personal than that.
Let's say, for example, the second floor of where you live right now, you turned into a little vacuum chamber, right? You know, like 20 feet by 30 feet or whatever, right? And you put a valve above your head and a lever, and you pull that lever. What happens? It's not like the movies. It is instant. It is violent. The air will absolutely equalize in a fraction of a second. You know, any deep sea diver will tell you this. Anybody that works on oil rigs, any submarine people, they will all tell you this. It is extremely violent. Pressure next to non-pressure, even though you can't see it. You know, like right now, what we're breathing in right now is not nothing. It's 80% nitrogen and 20% oxygen, right? So what happens when you pull that valve above your head? It just fires up instantly. And in fact, you'll probably black out. You might even die.
And so right when it gets to full vacuum, this mylar will rupture, and so it will be a catastrophic sudden failure, which will simulate what would happen if you were in space and suddenly the wall behind you got blown out. Whoa!
So when you go outside, why is our atmosphere still here? You know what I mean? Meaning our atmosphere sits right next to the vacuum of space, the purest vacuum of space. I've talked to vacuum chamber experts. You know, and when you have a pure vacuum, it's like orders of magnitude even stronger. So your first and only knee-jerk response to that will be gravity. Gravity. Oh, gravity is obviously holding the air down. I go, you mean the same gravity that couldn't keep the air in your living room from rushing upstairs? That gravity? The exact same gravity? Mm-hmm. And then people kind of get stuck because they know, you know, science says, well, it has to be gravity, otherwise we'd be dead. And I go, that's not how the logic works. What is the barrier? And they say gravity. And I go, gravity is not a barrier. Tell me what happens when you get to the bleeding edge of space, where our atmosphere ends and space begins. Tell me what happens. No science can tell me. They just stuck. And they just said, well, it's got to be gravity. And that's the end of the discussion. It's like, and it's because it's the only option for them. I go, other than being a pressurized system, you know, that we're living inside a dome. We're living inside a snow globe that's holding the air in. I mean, there's a reason why they call it air pressure. Oh, and while we're at it, there's a reason why they call it greenhouse gases. Doesn't it make more sense if it's an actual physical greenhouse? I never understood that even before I was into flat Earth. You know, when fluorocarbons, when we were talking about the ozone layer, we're banning styrofoam things at McDonald's, and we're banning underarm aerosol deodorants because
Cans
like,
of
oh no, the
hairspray.
fluorocarbons get up to the atmosphere, they just stay there.
Yeah.
And as I'm getting older, I'm going, how do they stay there? So anyway, that's my big cling to. But most people, it takes them a while because again, a vacuum is invisible. You know, you could be sitting in a vacuum chamber right now and visibly, because of our spectrum, what we can see and what we can't see, no one would know.
I just wanted to share that with you real quick. There's a lot more to it, but if I had time to go through every video I've made over the years, you'd be here for a very long time. Okay, so I like the example there of the vacuum chamber above your head. If gravity keeps all of the air okay, from rushing out into outer space. Okay, if I stuck a vacuum chamber above my head, then gravity should be strong enough to prevent all of the air from rushing inside that vacuum from over my head. So, do we have any questions, comments, or rebuttals for what has been presented so far? Yes?
If the atmosphere is just where the air stops, how does that mean the gravity stops where the air stops?
I never said gravity stops where the air stops. Yeah. Any other questions? Yep.
If the gravity is pushing the air to a certain point, why doesn't it push it all the way down?
Can you say that again?
If gravity makes the air stay in the atmosphere, why doesn't it push it all the way down to the ground?
I don't claim gravity keeps all of the I don't claim gravity keeps all of the air in the or close to the Earth. Like the whole claim that NASA claims is that gravity keeps the atmosphere contained. Okay, my claim is that the vacuum of space, okay, should suck all of the atmosphere right off the Earth. Gravity is not strong enough to be able to do that. So in order for that to happen, we actually need a contained system. The Bible here talks about the firmament of heaven, okay, which is spread out as a tent to dwell in. That was kind of one of those things. You have another question?
So under that theory, why does the atmosphere get thinner as you go to higher elevations?
That's a great question. And when we look at Mount Everest, okay, Mount Everest, you need like a breathing apparatus to go climb to the top of it because, as you said, the atmosphere gets thinner. However, when we look at the top of Mount Everest, there's still air there. We can actually still see clouds up above our heads when we go to the top of Mount Everest. Okay, so there's still atmosphere there. It's just a different consistency. There's different things there. There's different kinds of gases there that we can't really breathe in. And so, yeah, we hear about like helium. There's a lot of helium up in the atmosphere. We get into which we can't really breathe helium. We'll die. So we need to get a higher concentration of oxygen, particularly. Does that help with different gases?
All those gases are there together, and because of the difference in consistency of the gases,
there's a different consistency. There's a consistency of oxygen, which we can breathe, which is close to the Earth. But then once you get up higher, it's no longer a dense consistency of oxygen. There's actually different layers of gases out there that are heavier than oxygen, and there's other gases that are lighter than oxygen. I think it was called, I'm having a slip on my tongue. The superfluid, I can't think of the name, I'm sorry, but there's a kind of a gas that you can pour into a kind of a fish tank, and you can actually like float a boat on top of this gas. I just can't remember the name of it.
Will you pick up the boat? Okay, here's the secret. Hold on to it here like this. You hold on to that end. Okay, ready? Let's just set it in here like this, and we're gonna let go. Ready, set, let go. It's floating on a sea of sulfur hexafluoride.
So cool.
Does that look like magic or
Yes.
what? All right, so I want you to sink the ship. Ready? Reach down here and scoop up some gas. Does that feel dumb that you're scooping up gas? Now pour it in here. Did you see that? Do it again. Scoop up some more gas. Now slowly pour it inside. Do you see it? Keep it. There it is.
Yes.
You sank it. All right, so to prove that this is really true, here. Ready? Let me scoop some up. Okay, here we go. Good. It feels like you're playing imagination, right?
Yeah.
All right, here. Open your mouth. Okay, ready? Here you go. Breathe it in. Now talk.
Sulfur hexafluoride is sick.
It is. And my voice sounds awesome.
So when you say heavy, so you believe gravity exists.
There's a whole other ball of wax right there, but kind of going with the concepts here. 'Cause I'm more of a it's a electrostatics person. Okay, yeah, that's a whole other debate field there. But I'm just kind of going with the main concepts of it. I still acknowledge that things fall to the ground, and I just think there's different forces for it. You talk to Neil Tyson over there, and Neil deGrasse Tyson will say that what is gravity, and he'll say I don't know. Next question.
What is gravity?
I have no idea. Okay, next question.
Wow.
No, here's the difference. We can describe gravity. We can say what it does to other things. We can measure it, predict with it. But when you start asking, like, what it is, I don't know.
And so I try to be a little bit more insistent. I try to pull up my magnifying glass a little bit more and try to identify exactly what it is. Yep.
Okay, this firmament, what is it?
What is it? All I know is it's kind of spread out like a tent to dwell in. It's kind of a hard surface that keeps the atmosphere contained. As we just kind of demonstrated, the atmosphere needs something to contain it. If there's a big giant vacuum, which is far more intense than any vacuum chamber we could ever simulate here on Earth, then yeah, the whole logic
So
there goes out the window.
You don't know what this firmament is, this hard firmament is made out of?
I've never touched it, so I couldn't tell you.
How far away from the Earth is it?
Like I said, I've never touched it before, so I couldn't tell you.
My next question is there anything on the other side of it?
If I've been to it, I'm not aware of any explorers who've made it there. The Bible, if you kind of want to go with that whole thing, says that God dwells in the firmament, okay? Not under the firmament, but in the firmament, okay? That's a physical location of where heaven is. And the Bible also talks about stars being in the firmament, as well as the sun and the moon being in the firmament, okay? Not under the firmament, in the sky. Yeah.
So if there's a hard material holding the atmosphere in, so you said, right?
There's a solid surface of some sort. Exactly what material it's made of, I don't really know.
Yes.
Yes. But
how do we get rockets and satellites in space?
that's a great question. We will come back to that. I promise. Yes?
So according to your theory, you said in a vacuum, gases expand.
In a vacuum, gas will expand until it fills up the entire chamber. That's right. That's right. That's what we observed with the balloon in the vacuum. That's actually how our lungs work with our diaphragm. It works with the vacuum, and every time we breathe in, we kind of create that vacuum effect, and it fills our lungs with oxygen.
So if gases are made up of atoms, are the atoms expanding, or?
I don't know about. I've never observed the atoms to be expanding, so I wouldn't be able to answer that question. Yep.
Are you aware of the space-time as a fabric theory in relation to gravity?
Yes.
And Newton's law of gravity?
Yes.
And how both of those give off theories?
Okay, so what part of gravity says that, what part of Newton's law says that it would be strong enough to be able to keep the atmosphere from rushing into a vacuum chamber?
It does, is what happens. The Earth's atmosphere is a gradient. It doesn't officially end because the sun's gravity is pulling the atmosphere towards the sun. But since the Earth is closer to our atmosphere, it pulls it closer to the Earth. And the heavier elements stay closer to the Earth because the mass is more. And since
Okay, slow down. So you're saying that the Earth's atmosphere is continually getting kind of shooting out into outer space?
Correct.
Okay, that's your claim. That it is doing that.
And it's not a claim, it's a theory.
Theory.
A scientific one with evidence and papers.
There's a hole in the side of the spaceship, right? It's like, oh Lord, we're decompressing. We only got 2 minutes of air left, right? Get the duct tape, and it's this race against the clock. It's like, no, it's instant. I mean, it's a fraction of a second. And if you ever see that in a space movie, which is why I know it kind of dates me, the James Cameron movie Aliens from years ago, right? The end where Ripley opens up that door to space, right? Everything's getting sucked out. She's fighting, climbing the ladder. It's like, no. She's dead. The little girl's dead. The alien's dead. The Marines are dead. Everybody's dead. Movie's over. Roll the credits.
We can only have a pressurized atmosphere so long as there is a container. The existence of our atmosphere proves there is a firmament above our heads.
And it's not a claim, it's a theory. A scientific one with evidence and papers.
I've got just hold the board. I would love to see your papers and share your evidence on that. And I understand, like, right here in the moment, you don't have those on you. And that's like, this is kind of like dipping your toe in the water here. And so the whole Miro board that I introduced you to in the very beginning allows us to not just dip our toes in there, but to fully dive in and to research this stuff in depth. So I can fully research your papers, because I have not read your papers before. Yes?
So would you say that your interest in this came from a more spiritual perspective versus a scientific perspective, and then now you're kind of backing it with some scientific things you're learning?
There is a spiritual aspect of this. That was kind of the thing that kind of opened my eyes. And that's been like a really interesting thing to it, okay? Because, I've gone and read the Book of Mormon, and I've had a big spiritual confirmation for reading that. And then I took the same Book of Mormon challenge and applied it to my textbooks, and it's been a vastly different experience. It's like, wow, I wasn't expecting all that, to actually do that. And so I believed in a globe for my whole life until, was it 2016 or something like that? And after I started looking into all of this, and that's when my eyes started to become opened, and I started to really, this whole experience of praying about it really helped me to read my science textbooks with like a hyper amount of skepticism. My wife and I over here, we did a series on just reading our textbook with new eyes, kind of, because that's what I like to do. I like to read these papers, the scientific papers, and because so often these science books will just go ahead and they'll make a whole bunch of unsubstantiated claims. They'll say, scientists say this, scientists say that. And it's like, what scientists? Where? And then the book never says anything. It never substantiates the claim. This mountain is this old. How do you know? And so I'm like looking in the textbook for something to substantiate the claim, and they're just saying, this is so because he said so. I'm like, that's not good enough for me. So yeah, that's kind of what it's all about. And so, like I said, it wasn't until I started to do the research, that's when my eyes became open to. And so there's kind of a spiritual experience in that, but there's still very much a scientific experience in this as well. Does that help? Okay. Any other questions on what we've talked about so far? If not, I can write the question down for later if it's not related to the topic.
I have a scriptural question.
Yes.
So with the, the earth being like the footstool, like the disc, and then the heaven being the throne, I guess my question is like, how do you determine what's considered like figurative or metaphor versus literal in the scriptures? Because multiple times it says, the Lord's our shepherd and we're his sheep, but we're not, clearly not physically sheep. So would you say that by that extension that the heaven is physically shaped like a throne or a chair beside the earth, or how would you go about that?
When it comes to writing, you don't exactly use a metaphor for another metaphor. Okay, so we've got one metaphor here. Okay, the earth is like a footstool. Okay, it's likened to a footstool. So that right there is a metaphor. Now, if you want to add another metaphor onto that, now you got three metaphors. Okay, a metaphor for another metaphor, and yeah, I just can't follow that logic. If I was a writer, I want to be as clear and just kind of stick to one metaphor at a time. You follow? Okay.
Got one more question. Okay. You made a big deal about the map. The different entities use this map.
Yeah.
And it's spread out like that. You have airlines that fly worldwide every day. And pilots, they fly here, there. So I went to Cambodia. We went to LA. We flew to China. We flew to Vietnam first. And then we pick a route, we know exactly how much fuel it is. And now those countries over there, when, according to your map, for somebody that's over here, on this far edge of your map, how do they fly to the very far edge of on the other side? How do they get from one far spot on your map to the other far spot on your map? Do they go this way? Do they go around? How do they go around?
I really want to address that. We've got a whole section here about maps and GPS that I would love to get to, and that's when we're going to talk more about satellites and other things like that. So if you can hold on to that, I would love to address it. Yep.
So what would you say is like the end of
Where is the end? I've never been there, so I couldn't tell you. So, yeah, if like the end of the Earth, as far as we know, is Antarctica. That's just the edge of our understanding, but it could definitely go well beyond that. But I've never been there, so I'm not aware of anyone who has, so I can't exactly answer that question.
I was just going to say, like, on the flat Earth map, Antarctica goes all the way around the circle this way.
Yeah. Well, like I said, we'll come back and talk about that.
But we're not even allowed to travel out there with, like, government guidance.
Yeah. So we'll come back and talk about that real soon. Are we okay to continue on? Or do we have... Yes. Okay. I get it. You always think of the best things to say after the moment has passed. So come check out our Miro board. This is my main base of operations. It's totally free, no downloads required. This is my opening menu where you have a whole bunch of different flat Earth topics to choose from. Here in section 7 on the firmament, there's a little blue arrow in the corner. We'll go ahead and click on that. That just warped us over here to our section on the firmament. This is the video that I shared in my presentation on the vacuum of space and how it should affect our atmosphere. This is Mark Sargent's original source video, where I got the sound bites I needed to make this video. Now down here you'll see a bunch of gray boxes in a line. That is where I have the entire transcript of everything that was said in this video. Now, if there was anything that was said in the video that you disagree with, what you do is just go over here and grab the shape tool, and then we're going to go ahead and draw a little box right underneath that statement. Then in that box, you just double click it, and then you can write, I disagree with that because of this, and just explain your reasoning. Then I like to be color coordinated and color my boxes red that have disagreements in them, so that way they're easy to identify. Then if someone wants to present a counter argument, you just click the little blue dot at the bottom, and there you go. You can do this as many times as you like. And if you want to make additional points to the same argument, you just click the blue dot again. And there you go. Now this is how you present multiple points against a single claim. There's room for every argument, and if someone fails to address something, it's plain and noticeable. This stuff is easy, and it makes sense. This is how you take debates to the next level. Everything on here gets saved and backed up, and my favorite feature is right here. You can have multiple people working on the same board at the same time. So let's hear what you gotta say, in a systematized manner, as science demands. There's a link in the video description.